Charles, the inventor of the BioBlaster from Prozone Solutions. And today, I had a friend of mine who owns a mold business in Columbus, Ohio, bring in some of the lower-priced ozone machines that he's worked with over the last year. He brought me two machines. One is a little bit older than the other. I think this one's slightly over a year old, and this one is slightly over 9 months old. This one seems to still be working at this point. This is the cruddy little toolbox that came from the manufacturer. And while this one appears to be functioning, it is not seeming to function at the normal output, so we're going to take that apart and figure out what's going on with it. And you can see how everything's already corroded because it's a low quality box. And then inside of this machine is his non-functional machine that's been in service for a little over 9 months in the field and ceased to function. So what we're going to do today is we're going to literally expose the contents, take this machine apart, figure out what's gone wrong with it, and then we're going to develop a plan to repair it and to repair it in a way that it will work permanently. And the way we're going to do that, folks, is we're pretty much going to scrap the whole thing, take the guts, and build it into a better machine, the BioBlaster from Prozone Solutions. So what we're going to do, folks, we're going to take apart this machine that's not functioning anymore and figure out what's gone wrong, why it's not functioning. So we'll cut back in just a few minutes and show you what we've discovered. Now, I decided to turn this unit on before I completely take it all apart, and there are 1, 2, 3, 4 cells out of 7 that are not functioning, and you can zoom in on the output there. You'll see it's actually making a really bad noise, and it's shorting out and zapping. Potentially a fire hazard, I don't know. Hopefully the fuse would stop that before it ever started a fire. So you can see, folks, we've got off the end caps, we've taken out the big screws, and we pulled out this tiny little computer fan. This is just stuffed in the end here. It's not fastened really in any kind of a shape or form. We're going to take off these wing nuts and take a look inside and expose the heart of the problem and the inefficiency of this design. So just stick around. Okay, folks, you can see we're exposing these connections, and they use non-insulated, non-coated connections, and these have begun to oxidize pretty considerably in the last 9 months due to the ozone. And then when we slide out the heart of the matter, the heart of the unit, we can see that it's basically nothing more than a tiny little computer fan stuffed in the edge with no screws, a transformer, and then a cruddy little generator cell. And you can see this cell has been allowed to slide around inside. It's not even square anymore. It's held together just with the tension of the two plates. And the way that ozone gets made, folks, is air has to pass from the computer fan around this gigantic transformer, which is hogging the entire airflow of the cabinet, and somehow make it across to these electrified screens. And in this machine, it's not functioning and it's shorting out. We're going to take it apart and figure out why here pretty quickly. But again, inefficient design, vinyl fence post, $7 computer fan, transformer that blocks the output of the said computer fan, and a cruddy little homemade generator cell. And if you want to compare that, folks, to the supply of the BioBlaster Home Edition, you can see that in our machine the transformer is not mounted anywhere near the output shaft, and we have a unique patent pending ozone tunnel technology that lets the output from the air blower go directly over the generator cell and then shoot out of the case at 1 horsepower worth of pressure and massive CFMs. So this is a home ozone machine on steroids, and it's also been engineered in a way that it's virtually unbreakable, as opposed to the unit that actually failed in moderate service after only 9 months in the field. We're going to take this all apart, folks, and when we get back we can show you right here. One of the connections has actually burned through the dielectric, and that's an important point, folks, in how these machines are made. You see, they don't have the advanced hydrogen technology that we employ in the BioBlaster, and so consequently it's been traditionally accepted that there's no way to weld stainless steel screen to copper, because to get a heat hot enough to make the stainless steel able to be welded, it would actually blow through or melt the hole in the screen. But using an advanced form of a hydrogen technology available here only at Prozone Solutions, we've discovered a way to actually weld our connections. And you can see here that inside, if you get close, you'll see that this connection here is just a wire that's inserted into the copper mesh, and it's got a dab of silicone on it, and you can see the silicone's been burned away and the wire is actually oxidizing. I suspect that's the cause of the failure here. A little bit more exposure, you've got further oxidization cell by cell. There's another one. You can see the oxidization, and right here, folks, you can see our first almost burn through of the dielectric plate where that oxidizing mesh is in direct contact. And as we take these apart, we find another spot where it's almost oxidized through. In fact, this came apart. We've got more oxidization. See that green patina on the wire? That's because it's not welded, folks. It's just raw copper wire stuck inside the mesh with a silicone connection. And now we get to the heart of the matter. This is what was causing this to actually malfunction. You can see it's actually shorted through the wire here, shorted through the silicone. It's oxidized, and in fact it's actually burned through the dielectric medium here. And if you see, there's a close-up, there's a burn through and a hole. That's what was causing this machine to short out and burn through. And that's completely eliminated by our far superior cell design and our actual welded wires. And here's the second one, almost ready to burn through, that has started to oxidize and turn black and green, and the silicone is not present where it needs to be. So that's a little home Max Blaster unit. They're used by some professionals when they want to put multiple units in big areas, but in fact this $450 machine failed in less than 9 months of commercial use. And I'm not knocking, this is a dandy little machine. I actually used it in my business. It's one of the ones that I took apart when I was designing the BioBlaster 3, and that's why we took the design flaws from this machine and from all the other machines that we had, and we took the weaknesses away and infused the strengths along with my superior concept and built the workhorse generator cell, the ozone tunnel, with a patented 1 horsepower blower and ozone tunnel system that makes this the world's first virtually indestructible direct ozone output machine. And in fact, folks, there's no ozone getting into the ambient case of our machine because it's all being generated directly here inside the ozone tunnel and then being ejected far away from the machine. Folks, if you have a mold problem, an odor problem, and you want to destroy it permanently, I urge you to just buy now, because our machines are priced at 1/3 of similar competitor models, and when you compare them to tiny little homemade jobbers like this, for average homeowners that are sold on eBay and things like that, there's literally no comparison. Just look at this mess. What a piece of work.